You all are good and doing well for the preparation of your CAIs. Guys, today we are going to solve AS paper 1, course code 9709/12, May June 2023. Before we start the solving the paper, guys, you need to be very careful to fill this title page like candidate name, center number, and what else you have your candidate number. So these details you can find from the statement of entry, and you need to be very careful while filling this before you start the exam. Right? Okay, now we are going to solve the paper. This one. Suppose your candidate name is AR, center numbers PK 786, here candidate number 7869, candidate number. Now the first question you have to solve. Okay, the first question is about the case taken from the differentiation and integration. The equation of the curve is such that dy by d of x is this. You are given dy by d of x, that is 4 over x minus 3 power cube for x is bigger than 3. So the curve passes through the point 4, 5. This curve is passing through point 4, 5, and we have to find the equation of the curve. So for here, we need to make a separable equation, like keep the dy one side and the other x terms with the differential dx on other side. Now we can rewrite this as well. 4 times x minus 3 power minus 3 d of x. Now integrate on either sides. So derivative or antiderivative will be cancelled. So y equal to 4, as the power rule of integration, it become minus 2 by minus 2 plus c. So it comes minus 2 over x minus 3 power 2 plus c. Now for value of c, we need to find replace x with 4 and y with 5 here. We will get the value of c, like 4 minus 3 square plus c, 5 is equal to minus 2 by 1 square plus c, 5 equal to minus 2 plus c. So c becomes 7. Therefore, we can say required equation of the curve is y equal to, just you need to replace the value of c here, is minus 2 over x minus 3 square plus 7. That's the answer. I hope you got it. Okay guys, in question number 2, we are given the coefficient of x4 in the expansion of this is p, and the coefficient of x square in the expansion of this is q. It is given that p plus q 276. Find the possible values of the constant a. Okay, so what to do? We have to first write x plus a power 6, that help us to find the coefficient of x4, and that should be e. So for indicated term, we have ncr a raised to power n minus r p raised to power r. This formula, even you can get it from the formula sheet, which will be provided you along with the question paper. So here tr plus 1, n is 6, r will remain r, a is x, 6 minus r, and b is a power r. Fine. So for, as we are interested to find the coefficient of x4 here, so for coefficient of x4, we will equate this equation 1, coefficient of x with this. It means x power 4 will equal to x power 6 minus r. By comparing the power, we get 4 is equal to 6 minus r, so r will be 2. Therefore, term involving x4 is, replace r2 in equation number this one, this equation, and we will get 2 plus 1 is 3 is equal to 6c2 a raised to power 2 and x raised to power 6 minus 2, that becomes 6c2 a power 2 x power 4. Therefore, coefficient of x4 will be, you can use the calculator to find the 6c2, c2 c2 will give you 15a2, and it is given that this coefficient x4 is equal to what is p, so we can say this is what p. Similarly, here here we will use the second, it's given, and the coefficient of x square in the expansion of ax plus, also we can write 3 power 4, and that is equal to q. Now we are interesting to find the coefficient x square, so applying the same rule, tr plus 1 ncr a raised to n minus r b power r, so r plus 1, n is 4 here, r is r, a is what, ax power n minus r, b is 3 power r. So further simplified, 4cr 3 power r, a power n minus r and x power n minus r. I just split this term a and x with the common power. Okay, suppose this is equation number 2. Now for coefficient of here x square, we will see x square equal to the term involving from 2 x square x power n minus r, n is what, 4, so you can write 4 minus r here, here 4 minus r, here 4 minus r, right, here 4 minus r, so 2 equal to 4 minus r, r is equal to 2 here again. Now therefore term involving x square is, now replace into here, we get r2 plus 1 3 is equal to 4c2 3 power 2 a power 4 minus 2 and x power 4 minus 2, that is with the calculator, 4c2 comes to be 4c2 is 6 and 3 power 2 is 9, 6 9s are 54, a power 2 x power 2. Therefore we can say the coefficient of x2 for the expansion is equal to 54a2, and that is equal to given q. In the statement is given it is equal to q, so this is the second case. Now it is also given that p plus q is equal to 276, given that, and we have to find value of a. So now replace the value of p and q here. P is from here, it was 15a square, and q is what, 54 a square, that's equal to 276. Once we add it, we get 69 a square is equal to 276 a square. 276 divided by 69, we will calculate, we will get 4. So a equal to plus minus 2, taking square either side. This is the final answer for this part. I hope you got. Okay guys, in question number 3, it is given to express this in the form of this one, so it means we have to do this by using completing square method. So for that, if we can take common first, 4x square minus 6x plus p, Now the rule says half of 6 is 3. So 3 square will be added with it and minus with it the same plus b. So here we will see what we will get. We'll get 4 and these 3 term will be x minus 3 whole square and this minus 9 plus p. We will expand it. 4 times x minus 3 whole square minus 36 plus p. So 4 times x minus 3 whole square plus p minus 36 is the required form, which is the required form like a into x plus b whole square c. By comparing this and with this, where we can write where a is equal to 4, b equal to minus 3 and c equal to p minus 36, right? This will be the answer of first part, question 3. Now question b part of this one, hence or otherwise find the set of value of p for which the equation this has no real root. As guys you can see here, if we as we have the a is positive, a is greater than 0, so the curve will looks like to be this one. If it has two solutions like this, but as it is given it has no solution real root, so this case is real root. So and one case is here real root, one is with tangent line, but as it has no real root, it means the curve should exist above the x-axis, right? It should be above the x-axis. So and we have to find the set of value of p for which the equation has no real roots. So for this case, from the it's 1 mark, so from the above, what will be the vertex of the case, that is 3 and p minus 36. Turning point is here. So as it is above the x-axis, so we will go with the y. So p minus 36 will be greater than 0. So it means y coordinate must be greater than 0 because the curve is lying above x-axis. So it should be greater than 0. Y coordinate should be greater than 0. So p will be greater than 36. That is the right answer for this question number 3. I hope again it is clear to you. Okay. Guys, here we have question 4. Solve the equation. This one, 8x6 plus 215x3 minus 27. This we need to solve by converting this into quadratic. Let t is equal to x cube. So t square will be x6. So we'll see 8t square plus 215t minus 27 equal to 0. Now you can use any quadratic formula or midterm break rule to justify your answer. We get t is equal to 1 by 8 and t equal to minus 27. Once you will solve this with the help of calculator or by midterm break rule. Now it is not end over here. We need to resubstitute the value of t from here 1 by 1. So when x cube is 1 by 8, so you're taking cube root on both sides, we'll get cube root of 1 by 8, that will be calculated as 1 by 2. Right, this is the one answer. And the second one, x cube is equal to minus 3. So taking cube root minus 27, sorry, taking cube root of minus 27, and with the help of calculator we will get this minus 3. So these are two our solutions, x 1 by 2 and x is equal to minus 3. Okay guys, in question number 5, the diagram shows the curve with equation this one for x is greater than 0. The curve meets the x-axis at point this and this, 0 and 4. find the area of the shaded region. So from the formula sheet, again it will be given to you. The area for the shaded region along x-axis is integral of y d of x, and here it will be x1 say x2. So as from the point 0 0 and 4 0, and if from the figure we have 0 and 4, so x will be x1 will be 0, x2 will be 4. So we will integrate it. Area is equal to 0 till 4, y is 10, here it is given, here the y, 10 x power 1 by 2 minus 5 by 2 x power 3 by 2 d of x. Apply the rules of integration, we will get it 10 x power 1 by 2 mean it becomes 3 by 2. Once we add it, and 2 by 3, it means it becomes 20 by 3 minus 5 by 2 times x power, once we add it, 3 by 2 plus 1, 5 by 2, and 2 by 5, and limits will be 0 till 4. It will be cancelled. Okay, fine. Now finally 20 by 3 x power 3 by 2 minus x power 5 by 4. Now apply the properties, how to apply the limit, upper limit minus lower limit. So we will replace the values of x 1 by 1 with first with 4 and then with 0. So we'll get 20 by 3 4 power 3 by 2 minus 4 power, this is 5 by 2, 5 by 2 minus, once we put 0 lower limit, 20 by 3 into 0 power 3 by 2 minus 0 power 5 by 2. 5 by 2. Okay, we solve this. Once we solve it with the help of calculator, we will get the area of shaded part. Area shaded, we can write area of the shaded part can be calculated as 64 by 3 or 21 whole 1 by 3 unit square. That's the answer. Fine guys, this is question number 6, and we have given this figure. The diagram shows a sector AOB with of a circle with center O. The angle AOB is theta radian and OPOX is equal to x. Show that the arc length AB is 2x theta cos theta. Okay guys, if you can see this figure, I'm going to draw for you separately. Right, this one, this is P, this is O, angle theta in radian is this is x, this is x. So this is case study for the isosceles triangle. In order to find the arc length formula, we know arc length is equal to arc of length of AB, that is L is equal to r theta. So we are looking for this value of r theta, where r stand for OA. Any OA and OB both represent the radius of the circular sector. Okay, fine. For this, as it is isosceles triangle, so it has both base angle same theta, and we can, if we draw the perpendicular projection on the other side, it bisect the side. Mean if it PQ, suppose P and Q, this is the total length is OA, so it will be half of OA, and this will be half of OA. Now for a right angle triangle, P, Q and A, it is same like P, O, Q. We have cos of theta is equal to curly brown hair, base is half of OA, and hypotenuse is x. So we can say OA is equal to 2x cos of theta. Once you simplify this, we get this one. So therefore we have the arc length L is equal to R times theta. So R is equal to what? OA. So we can write L is equal to 2x cos of theta times theta. So we write 2x theta cos of theta. That is the required proof what we have to. This is hence proved. So we have proved it. Now we have to find the area of the shaded region APB in term of x and theta. Okay, fine. Area formula we know that's half of r square theta, and but area for shaded region will be, that will be half this area of sector. This was area of sector, right? Area of sector minus out of this total area, this one I'm going to write for you. See the figure. This total area of the sector, out of this total area of the sector, if I cancel this area of this triangle, this one, so only then area of shaded part will left. So we can write area of sector minus area of triangle OPA. So by using specified rule here, formula, area of sector is half r squared theta minus area of triangle is half AB sine theta. So substitute the values. 1 by 2, r is what we have already calculated, r here with red, that was 2x cos of theta square times theta minus 1 by 2, and here AB sine theta. For the triangle we can say theta is what here, we can say this theta, if we say this is A, this is B, this is pi minus theta, right? Pi minus 2 theta, because of isosceles triangle it will be pi minus 2 theta will give us this angle. So half AB is x, then x sine of pi minus 2 theta, right? As we have to show our result in term of sine theta and theta and cos theta and x. So here we will see 1 by 2 into 4 x square cos square theta, and this theta will be here. So write theta by 2, right? I can't multiply this theta with the angle with trigonometry. Minus it will be 1 by 2 x square sine of pi minus 2 theta, right? Okay, here we have to solve it further. Simplify it for 2 2s are 4. So 2 theta x square cos square theta minus 1 by 2 x square, and this whole term becomes sine pi minus pi mean 180 minus 2 theta will be sine of 2 theta, and sine of 2 theta can further be written as sine of 2 theta will be 2 sine theta times cos of theta. This is the trigonometry identities. So we can shift this one as what is will be common here. If we want to take, okay, take x square common. From here we get 2 theta cos square theta minus 1 by 2, and it will be 2 sine theta cos theta, sine theta cos theta, close it, 2 to cancel, x square 2 theta cos square theta minus sine theta cos theta, sine theta cos of theta. Further we can take cos theta as a common here, so x square cos of theta times 2 theta cos of theta minus sine of theta. This can be the one of the solution in terms of x and theta. I hope it is clear. Let's proceed for the next case. Okay guys, in question number 7, by first expanding this one cos theta plus sine theta whole square, we have to find the three solutions. Then find the three solution of the equation. Okay, and the domain is given to be, range of angle is 0 till pi. Okay, fine. So first expand it, a plus b whole square, like identity, we are well aware about it. If you forget it, do write it 2 times, and then applying distributive properties of multiplication, we will get a square plus b square plus 2ab, right? Expansion of a plus b whole square. So applying here a first term, second term, we can write cos square theta plus sine square theta plus 2 sine theta cos theta, right? 2ab. And as the property we know more, trigonometry says sine square theta plus cos square theta is equal to 1. So it will be, this will be 1 plus 2 sine theta and cos theta, that is the expansion of cos theta plus sine theta whole square. Now we have to find the three solutions of the equations. Cos theta plus sine theta whole square equal to 1. So this is the, already we have proved that this is equal to 1 plus, let me change the color, this expansion from here. This is 1 plus 2 sine theta cos theta equal to 1. Shift this one to other side. 2 sine theta cos theta is equal to 1 minus 1, that becomes 0. So divided by 2, we have sine theta times cos theta equal to 0. So this gives us different solution. Once sine theta is equal to 0, so theta will be sine inverse of 0, and with the help of calculator we can get the values of theta here, which can be at 0 and pi at 0, even we 2 pi and so on, but we will not proceed more than the given domain of the values. So, and also we can write other function cos of theta equal to 0, so theta is equal to cos inverse of 0, and it will be 0 when this is pi by 2 or 3 pi by 2, but it will be more than that, so we will not take this value beyond this, the given domain. So as we are behind the three solutions, so which are the three solutions? Hence the required three solutions are, one is 0, then pi by 2 and pi. Fine. Now hence verify that the only solutions of the equation, this one, are this and this, lying between 0 and pi are 0 and pi by 2. So we have cos theta plus sine theta is equal to 1. So if we take the square on both sides, as in the part A, we solve this, the two solutions. We have to just verify that. From the first part, we got three solutions. So we need to substitute both solutions one by one, all the three solutions one by one here to find the right solution. Like when theta is equal to 0, cos of 0 is equal to cos of 0 plus sine of 0 equal to 1. Sine 0 we know the 0, cos 0 is 1 is equal to 1. So 1 equal to 1, left hand side equal to right hand side. Therefore, one solution is 0. Theta is equal to 0, right? Now, when theta is equal to, next one is pi by 2. So cos of pi by 2 plus sine of pi by 2 equal to 1. Cos pi by 2 we know that is 0, but sine pi by 2 is 1 is equal to 1. So 1, your left hand side equal to right hand side. Therefore, second solution is pi by 2. Now see the third, when theta is equal to pi. So cos of pi plus sine of pi equal to 1. Cos pi is minus 1 plus sine pi is 0 is not equal to 1. So it means minus 1 is not equal to 1. So your left hand side is not equal to your right hand side. So this is not solution. The final solutions are 0 and pi by 2. We can write the solutions number this, and these are the two solutions which are required for this case. I hope it is clear. Let's proceed to question. Okay guys, now we have to prove the identity in sine left hand side equal to right hand side. So taking left hand side, preferably sine theta over cos theta plus sine theta plus 1 minus cos theta over cos theta minus sine theta. Taking LCM, we will see cos theta plus sine theta times cos theta minus sine theta, and doing a cross multiplication we will get, once we write both, this goes here and this goes here for multiplication. So here we get sine theta cos theta minus sine square theta, and there we have, when cos theta plus sine theta multiplied with it, we get cos theta minus cos square theta plus sine theta minus sine theta cos theta, right? So here we can say this whole term can be cancelled with this one and nothing else. Fine. And we have sine theta plus cos theta, sine theta plus cos of theta, and this becomes minus, taking common minus from here and here, sine square theta plus cos square theta, and in denominator we have the identity that a plus b times a minus b equal to a square minus b square, right? We will apply it here. It becomes in denominator cos square theta minus sine square theta. Now we also know that identity is sine square theta plus cos square theta is equal to, yes, 1. So this becomes 1. So we write sine theta plus cos theta minus 1 over, and as in the proof you can see in numerator we got it. We just need sine terms. So cos square will be 1 minus sine square theta, and minus sine square theta is here already. So we'll get, we write according to the the proof, cos theta first plus sine theta minus 1 over 1 minus 2 sine square theta. That's your right hand side, hence proved. I hope you got it. Here guys, for the C part we have to prove this thing, that the first what we have done proved in part B, left hand side, that is cos of theta plus, and we can write from B, this side whole side equal to this one. I'm going to write it, sine theta minus 1 over 1 minus 2 sine square theta equal to this one, 2 times cos theta plus sine theta minus 1. And if you can see carefully, because numerator of both sides can be cancelled, we will get 1 over 1 minus 2 sine square theta is equal to 2 by 1. Do the cross multiplication. 1 is equal to 2 minus 4 sine square theta, and 4 sine square theta is equal to 1. 2 minus 1 is 1. So sine square theta is equal to 1 by 4. Sine theta is plus minus 1 by 2. So these are two results. Here we will get solutions. As the domain of the angle is lying between 0 and pi, so it means theta can be in first quadrant or in second, that is pi minus theta. And here we are not interested with this more than pi, right? So one here, 1 sine theta is equal to 1 by 2. So theta will be sine inverse of 1 by 2, will give us the values on the calculator. Let's see what it will be. Shift sine bracket 1 divided by 2, and we'll get 30 in pi. We need to change the calculator mod in pi because it is in pi, so pi in radian. So we need to change the mod of calculator mod in radian. So it will be pi by 6. One answer. And sine is theta is lying here and here, and theta is equal to pi minus pi by 6 will give us 5 pi by 6. Also, when sine theta is equal to minus 1 by 2, so theta will equal to sine inverse of minus 1 by 2. So with the help of calculator, shift sine of bracket minus 1 divided by 2, very close, we get minus pi by uh, here, yeah, minus pi, both are 2. So your solutions are, it will be 0, theta is equal to again minus pi by 6. Sine negative it can exist here, so this is not required for the given domain. For the given domain, because that is lying between 0 and pi. So third and fourth quadrant not the part of our solution, so these are two our solutions, like this and this. I hope it's clear. Let's proceed to the next question. Okay guys, the diagram shows the graph of y equal to f of x where sorry where the function is defined by this one. On the diagram above, sketch the graph of f inverse. We know that f inverse, graph of, you can write graph of f inverse is always, f inverse is always symmetrical to the line y equal to x, like y equal to x will be here, right? This is y equal to x and must be symmetrical here. So what to do? I need to do the calculation like this. Here it will be like this. So you can see each point is equal spaced from the other one or other side of the line of symmetry, same. So this is how we can we can draw the graph, because it must be equal spaced on either side. Now find an expression of f inverse of x. So for this, f of x is given to be f of x equal to 3 plus 2 sine 1 by 4 x, meaning x by 4. So as we know, f of x is equal to what? Y. Now we need to make here x as a subject. So let's shift this 3 on other side. We will get 2 sine of x by 4 divided by 2. It means sine x by 4 is equal to y minus 3 by 2. So x by 4 equal to sine inverse of y minus 3 by 2. Our target is to make x as a subject here. So do the multiplication on both sides with 4. We get y minus 3 by 2. As we have done thus x as a subject of formula, so we can say shift this one with x with f inverse of x, and 4 sine inverse of and y with x 3 by 2. That's the final answer for the inverse function. Okay guys, now for the C part of this question. The diagram above shows part of the graph of function g of x is this, and it's ranging from minus 2 pi till 2 pi. Here it's given here. Complete the sketch of the graph g of x on the diagram above and hence explain whether the function g has an inverse. Okay, I recommend you to draw a table here for the few values x and g of x, right? So as here, complete the sketch of the graph. So we can take different values, say here for this minus pi by 2, because the given functions keep the domain. We will take the value from 0 to 2 pi because that is the given function f of x domain. But here g of x domain keeps minus 2 pi to 2 pi. So take value of minus pi by 2. What comes on the help of calculator? I will just replace here g. Let's see, g of minus pi by 2 will be 3 plus 2 sine of 1 by 4 times minus pi by 2 on the help of calculator. When I will solve, I will get 2.23. Similarly, we can write minus pi as well, the next value here. G of minus pi equal to the g function here with 3 plus 2 sine of 1 by 4 times minus pi, and with the help of calculator with the radian mod I will get 1.59. Here guys, you need to be very careful while calculating this and keep the calculator mod at radian to get the best answer. So we will get 0.23 and 1.59, and similarly take more values on minus 3 by 2 pi, because maximum we can approach this here, and minus 2 pi. Minus 3 pi, same process. G of minus 3 pi by 2 will give me, I'm doing the calculation on calculator, and I will get, the result is 1.15. I will write 1.15 because this value will help me to replace at the right place at the point which is required. G of minus 2 pi will give me similarly, yeah, it is 1, so 1. Okay, and we also need to take this value on the calculator In radian pi is 3.14 because in radian pi is 3.14, and the half of it will be 1.07, yeah, 1.57. So our answer will be, it will be minus pi by 2 is 1.59, 1 point here, here, and then it will be here, and it will be 1 is approximately here. So we can say our graph is like this, right? And 1, this is the graph approximately drawn that help us to get this point. This calculation you must show it. Okay, next case, this is a 6 marks question, very interesting question. It's based on transformation. Given that, describe fully a sequence of 3 transformations which can be obtained by transforming of y sine x from 0 to pi by 2 to the graph of sine x, making clear the order in which the transformations are applied. Y equal to sine of x. So here it is given that in the question, I'm going back, we are given f of x equal to 3 plus 2 sine 1 by 4x. Let me write it here. F of x is equal to 3 plus 2 sine of, it was what it was, let me check again, plus 3 plus 2 sine 1 by 4x, 2 sine 1 by 4x, right? This was given, and we need to write the transformation for this. Here first of all, you can see, and along with it given 0 is less than equal to x is less than 2 pi. Okay, fine. So here it goes. We have to write the first transformation. You know, this case study I'm going to write with different colors. This is the horizontal stretch with stretch factor 4. That is the reciprocal as per rule of stretch. For this case, you need to revise all the transformation rules when stretch along x-axis, when set to be long stretch along y-axis, yani vertical stretch, and when it is taken as a translation along x-axis, y-axis, and reflection. 3 cases you have to recall from the rules. In the past videos, I have explained it. Okay, second case is about this two, and you know, this is the multiplication, so we can say vertical stretch with stretch factor 2, and vertical it will remain same. And finally this 3 is said vertical, or vertical mean y along y-axis, horizontal mean along x-axis, vertical translation of factor 3. That means we can write 0 and 3. So this is 6 marks with these 3 lines. I hope it is easy and you got it. Guys, this question is taken from the case APGP. It's given the second term of geometric progression is 16 and the sum to infinity is 100. So it means second term for GP, we know general term of GP are A, AR. We can write general terms of GP, AR, AR square, and so on. And sum to infinity, we know that A over 1 minus R. These are the r is less than 1. We know these conditions. So according to question, the second term is given AR is 16 and S infinity is A over 1 minus R, that is equal to 100. From here we can write, as we are looking for two possible values of the first term. First term is A, right? So first term is equal to A. We are looking for two values of A. So from here we can write R is equal to 16 by A. I will put this 1 in 2. Put 1 in 2. I get S infinity, that is A over 1 minus 16 by A equal to 100. So it becomes A square over A minus 16 is equal to 100. I will simplify it. A square minus 100 A plus 1600 equal to 0. Now here what to do? You can just simplify it to or apply the quadratic formula or the midterm break rule. I will have A minus 20 times A minus 80 will give me these factors. So two values of A are A20 and A80. These are the two possible values of the first term as to be asked. I hope it is clear. Let's proceed to the next question. Oh guys, now it's given to show that the nth term of one of the two possible geometric progressions is equal to the this. Okay, geometric progression, as we know the nth term of GP is an is equal to AR power n minus 1, and it will also be given in the formula sheet, so if you forget it. So here for A equal to 20, we got the values from the first part, and A is equal to 80. We have two possible values, so we need to solve them here. Implies that A n is equal to, this is first progression, geometric progression, A n 1 we can write is 20, R remains R, and n power R. Yes, we have need to find R as well. And before we put it here, we can see the first part. After evaluating, this value of A 20 and this, we can put in it in 1. So from 1, R will be 16 by 20, that is 4 4s are 4 5s are 1 value of R with A20. We get R is this, and when R is next value 20 80, so 16 by 80 will give me 1 by 5. So we can say with A is 80, R is 1 by 5, and we will use these values in the part B. So here we can see when R A20 will take R as 4 by 5 here, and next for with 80 will take R 1 by 5, right? So first solve one case, power n minus 1. We write A n 1, first term of geometric progression, 20 into 4 by 5 and minus 1. This is case equation number, say 1 2 was before in part, we can write it 3, right? Similarly here the next GP becomes with 80 R. R with 80, we know that is 1 by 5. So power n minus 1. Okay, suppose this is equation number 4. Now what to do? We can divide 3 with 4, because we have to find and we have to show that the nth term one or two possible geometric progression is equal to this one. Okay. So a n 1 over a n 2, the left hand sides divided by the, sorry, it will be 4 by 5 power n minus 1 divided by 80 times 1 by 5 power n minus 1. So we can further simplify it. Here you can see 20 and 80 will cancel and we get 1 by 4. This is 4 by 5 power n minus 1 and divided by 1 by 5 power n minus 1. 1 by 4 is 4 is to power n minus 1. 1 by 5 power n minus 1. I just split this one by applying the property a over b power n is a n over b n. So once I will take the separate power of 4 and 5, I can write like this and this, right? Divided by 1 by 5 power n minus 1. So here you can see this and this cancelled. We will get 1 by 4 and 4 is to power n minus 1. So apply the indices rule like this, same base with different power. Dividing, we can get this one. So 4 is to power n minus 1 minus 1. So 4 is to power n minus 2 is the right answer. What we have to prove here, you can see, hence proved. Hence proved. I hope it is clear. Okay guys, here it is given the equation of a circle. This one, the line, this one is a tangent to the circle. It means the circle and the line is a tangent, like here, passing in one point. Circles has center a and 3 with the radius square root 20, right? Given. Show that one possible value of a is 4 and find the other possible values. Okay, we have to solve this because tangent and they are intersecting it, so we need to simplify it. We will solve x minus a whole square plus y minus 3 whole square 20 and the line y equal to 1 by 2x plus 6 simultaneously. Okay, we will get it. And what to do, we'll have x, if we can further possible value of a is 4 and find the other possible values. For this case, x minus a whole square plus y will be placed with this whole values. So I will write x by 2 plus 6 minus 3 whole square equal to 20. So x minus a whole square plus x by 2 plus 3 whole square equal to 20. So become x square minus 2ax plus a square plus x square by 4 plus 3x plus 9 minus 20 equal to 0. So further, if I multiply 4 with each term, multiplying this 4 with each term to eliminate the denominator, we get 4x square minus 8ax plus 4a square plus x square plus 12x plus 36 minus 80 equal to 0. So now arrange the like terms. We will get 4x square and this becomes 5x square plus, and I'm going to write it 12 minus 8a times x from here, and the constant will give 4a square minus 44 equal to 0. Now as a case study for the tangent, so for the tangent we know the b square minus 4ac equal to 0. We have only one repeated solution, so we will apply b square minus 4ac equal to 0 for the case of tangent. So it will be 12 minus 8a whole square, 4 times a times of 4 square minus 44. Further simplification will give us a quadratic equation. I'm solving it. You better can just simplify it to get this a square, minus 16a square minus 192a plus 1024 equal to 0. So divided by minus 16. To make it simplify, we get a square plus 12a minus 64 equal to 0. The factors will be a minus 4, a plus 16, a plus 4, a plus 16 equal to 0, a minus 4, yeah, a minus 4 and a 16. So a minus 4 equal to 0, a will be 4, and when a plus 16 equal to 0, a will be minus 16. These are the two values. We must show that one possible value is 4, hence as here you can see the one possible value is 4, hence proved. We're not behind the other values so far. Now for a is equal to 4 in B part, find the equation of the normal to the circle at P. So suppose we have this equation number 1 here. So here we replace a with 4, we get 5x square plus 12 minus 4 is a 32 times x plus 4 square is 16, 4 is 64 minus 44 equal to 0. So 5x square minus 20x plus 20 equal to 0. Further simplify by dividing with 5 each term. We get x square minus 4x plus 4 equal to 0. And this is the completing square. We get a perfect formula that x minus 2 equal to 0. X comes to be the 2. So value of x is 2. Now for the coordinate of value of y, we need to put this x2 in the equation of circle, like here in the first part it is given that x minus what yeah, in the line even we can place it in the line. Line is 1, y equal to 1 by 2 x plus 6, sorry. So here we will put it in y line is what, y equal to 1 by 2x plus 6, right? So here I'm going to substitute it. It will be y equal to 1 by 2x plus 6. So when x is 2, y becomes 1 by 2 times 2 plus 6, y becomes 1 plus 6, 7. So therefore we can say the coordinates of the the point at normal are 2 and 7. So 2 and 7 becomes the point on which the equation of normal is going to be found. So therefore equation of normal at point 27 with the gradient as is normal. So from line, if line grade is 1 by 2, so it will be minus 2 is, we can write y equal to minus 2x plus c, as we are substituting in y mx plus c in this rule. So at point 27, here y is 7 minus 2 times 2 plus c, c becomes 11. Therefore required equation of normal is y equal to minus 2x plus 11. I hope it is clear. Okay guys, now the final part of this questions, C, it's again for A4. Find the equations of the two tangent to circle which are parallel to the normal, like here we have to find, this was the tangent, the case started, the center A and 3, this is normal, and two tangents that is parallel. So two, I can say these are parallel to the normal, this normal, right? This is normal, this is tangent 1, this is tangent 2, and for the parallel, and these are parallel. We know that uh, parallel lines have the same gradient. Therefore, here from the above in here, like I'm going to write with underline here, this one in the above part, we know that m is equal to -2 here. Okay, we will we will have put m is equal to y equal to, therefore equation norm tangent, therefore equation of tangents are y equal to -2x plus c. Now here we need different value of c that will define the tangent 1 and tangent 2, right? And how? We will substitute this value y here in the above question. Equation of circle, x minus, that was what, 4 whole square, as we can check it again. Sorry, yeah, a was 4, so x minus 4, here I'm going to put it, x minus 4 whole square plus y minus 3 whole square equal to 20. Let's see what comes the result, because a is 4, so x minus 4 whole square plus y minus 3 whole square equal to 20. So for y, I will put this one, because I'm behind the two values of c. So x minus 4 whole square plus y is minus 2x plus c minus 3 whole square equal to 20. Now I will expand it and further simplify. I will finally get 5x square plus 4 minus 4c times x plus c square minus 6c plus 5 equal to 0. You can expand it, okay, like a plus this has b whole square. After simplifying, finally we'll get this thing. And further, lines are tangents to the circle. Here you can see this, and this is a tangent as well. So for tangency of lines, what to do? We have b square minus 4ac equal to 0. So let me write with other color, ac equal to 0. So this is case study for the tangency of lines. So here b square means 4 minus 4c whole square minus 4 times a time of c square minus 6c plus 5 equal to 0. Further simplifying, expand this first and then simplify it. We will get c square minus 22c plus 21 equal to 0 with factors c minus 21 and c minus 1 equal to 0. We have two values of c, 21 and c is equal to 1. So by replacing it here in this static equation, we will get two equations of tangent. Therefore, required equations of tangents are when y equal to minus 2x and c when c is 21, one answer, and other one y equal to minus 2x plus 1. I hope it is clear. This is the end of this question. Now we are at the last question. Okay guys, now we are at last question of this paper. The equation of the curve is this. Find dy by d is so simple. So dy by dfx is equal to k times first right power. Make one less from the power, because this expression y equal to k, it can be written as 4 plus x plus 1 power 1 by 2 minus x plus 5. Okay, and times differentiate a function, it gives me 4. The 3 step of power rule, you need to recheck it from the last lesson, and x is 1, constant is 0, plus 0. So dy by d of x is equal to k by 2, and yeah, we can simplify it. 2 ones are 2 twos are 4. We can write it as 2k, and this minus because it is denominator to becomes plus 1 by 2 minus 1. This is the first 2 marks part. I hope it's clear. The x coordinate of the stationary points. For the stationary point, we always find dy by dx and we equate to 0. Already in the first part, we have calculated dy by dx. That is 2k over 4x plus 1 power 1 by 2 minus 1 equal to 0. So 2k over 4x plus 1 power 1 by 2 equal to 1. Do the cross multiplication. I will get this result is equal to 2k. Taking square on either side will give me 4k square. 4x will be 4k square minus 1. So x will be, x coordinates are 4k square minus 1 over 4. I hope it is clear. So this was the, okay guys, this is the now final part of the paper, May 2023 1 2. Given case 10.1, 10.5, find the equation of the normal to the curve and the point where the tangent of the curve makes an angle theta. It means theta is tan inverse of minus 2. So tan theta is equal to 2. As we know, tan theta represents the gradient, that is m. This is the gradient of the tangent. We can say it is the gradient of tangent line. So what will be the gradient of, as we are behind the normal, so what will be the gradient of normal? That will be minus 1 by 2. That will be the gradient of the normal line, because these two are perpendicular to each other, tangent and normal. So we have one gradient is negative reciprocal of the other. So from the first case, it is minus 1 by 2. So from the case here we have, yeah, divided 2k divided by dx is also representing gradient at point. So I'm going to replace k value k here and equal to 2. So here yeah, I will get 2k over 4x plus 1 power 1 by 2 minus 1 equal to 2. So shift is here, 2k over 4x plus 1 power 1 by 2 equal to 3. Now what to do? Just replace k is, that is given to be 10.5. 10.5 times 2 will be 21 over 4x plus 1 power 1 by 2 equal to 3. So further simplify and divide by 3, because 7 is equal to 4x plus 1 power 1 by 2. Taking square on both sides, 4x plus 1 equal to 49. 4x is equal to 48. X is equal to 16. So x coordinate will be 16. So for y, we need to put this in the back to the equation of original equation, as here I'm going to mention you here. I'll put the value of x and k here. We will get that y equal to k is what, 10.5 times and 4, x is 16 plus 1 power 1 by 2 minus 12 plus 5. With the help of calculator, I will get it 66.5. Therefore, equation of normal, what we are looking for, normal at point 16 comma 66.5 with gradient that is m is equal to minus 1 by 2 is y equal to mx plus c. So y equal to minus 1 by 2x plus c. So 66.5 is equal to minus 1 by 2 times 16 plus 6. 74.5 equal to c. So we can write the final equation y equal to minus 1 by 2x plus 74.5. This will be the final answer for the final question of this paper. I hope you understand it. Wish you good luck and see you in the next paper.